All right, today we are going to talk about exponential and logarithmic models. And the first thing is I want to actually show you what an exponential model looks like. So we'll start with exponential now. We'll get to logarithmic later. When you're talking about exponential growth, you could be exponential growth or exponential decay. So what you have here is essentially it's the same equation, right? Both equations are both, this first one is exponential growth. This one here is exponential decay. And they're exactly the same thing. They are a constant a times e. That the number that you essentially the base when it's ln, that's log base e, same e that's there, 2.718, whatever the decimal comes out to. We have y equals a constant times e to another constant b times x. Now, if b is positive, it's going to mean your model is growing, and if b is negative, it's going to mean your model is decaying. Other than that, the constant in front of e can change, and depending if b is positive or negative, that's your growth and decay. All right, so here we have this equation right here, where p stands for population in millions, and t represents 1995. So t equals 5 represents 1995. According to this model, when will the world population reach 6.8 billion? Okay, so they've given us a whole bunch, they've given us this equation right here, outlined in red. They've given us this equation, and they say, well, when will the population reach 6.8 billion? And here's the tricky part. Population is measured in millions. Well, what's 6.8 billion? Well, how many million is that? So if you think of 6.8 billion, that's 6,800 million. Right, these two would be equivalent. So when we're substituting a value in for p, it's not going to be 6.8, and it's not going to be the actual number 6,800,000,000. We're not going to write that. It's actually going to be 6,800 is the value that's going to be going in for p. So when I do this, 6,800 equals 5,344 e to the 0.012744t. Just by looking at this model, you should be able to tell me if this population is increasing or decreasing, because our value in front of our variable t is positive. This is increasing. So now that I've identified my equation, all I really need to do is solve for t, which is exactly what we did yesterday. This is not by itself written in exponential form, and the reason is we need to get rid of this 5,344. The only way to do that is division. 5,344. You're going to have to do that in a calculator, so these will cancel. And what I'm going to show you is we're going to try to be as exact as possible. 6,800 divided by 5,344. Enter. So I know I can write the abbreviation on here, 1.27, if you want to go 1.272, that's fine, equals e to the 0.0127444t. Well, how do I solve this? That's definitely exponential form. Now I'm going to put it in log form. That's going to be log base e, so I'm going to write ln of 1.272, that number I'm taking, that is going to be equal to 0.0127444t. Well, the ln of that big long decimal I can take in the calculator. Now, what I do not want you to type in is, I do not want you to type this into a calculator, what I just underlined in red. The reason being is that is not exact. I want us to type everything into the calculator. So when you hit that ln key, I just hit the ln key, you can see on the calculator. Then you want to type in the exact whole decimal. The easiest way to do it is hit the second key and then the minus key. Excuse me. That stands for answer. That is the last answer that the calculator got, which is the 1.27 long decimal that we want to reuse. We can now hit enter. We're going to have to do one more division because our next step would be to divide by 0.0127444t. Oh, not the t. Divide by 0.0127444. So again, I do not want to round. I want to use that entire decimal, so I can do second, the minus sign, bring up answer, then I hit divide, and then I type in 0.0127444, and I hit enter. That's going to be approximately, when t is approximately 19. Now, t equals 19 is not a year. We want to know, well, what year is that actually? Well, if we go back to the beginning and they tell us t equals 5 is 1995, well, then my question is, well, t equals 19, would it be what year? So it looks like the correct answer to this problem would be 2009. All right, let's try a similar problem involving some fruit flies. As a population of fruit flies is increasing according to the law of exponential growth. After 2 days, there are 100 flies. After 4 days, there are 300 flies. How many flies will there be after 5 days? All right, and I put a little question, a little hint here. We're actually going to need to use a system of equations. So they've told you that these fruit flies are growing in terms of exponential growth. So we know y equals ae to the bx is the format for these problems. What we don't know is we don't know the value of a and we don't know the value of b. What they have instead said, after 2 days there are 100 flies. To me that reads out as a coordinate. When x is 2, there are 100 flies. All right. And after 4 days there are 300 flies. So that should read out to a similar coordinate, 4, 300. So what I have here an x and I have here a y. I have here an x and here a y. Well, if I substitute these two coordinates, so let's take this this first one. I'll put the rectangle in blue around it. If I take that first one and I substitute it into my exponential equation, what I have is 100 equals, I don't know what a is, e is our constant, I don't know what b is, and I know that x is 4, so I'm going to call it 4b. Oh, I'm sorry, x is 2. My fault there. I'm going to call it 2b. So I got all of that from this first coordinate. That's our first equation in our system of equations. I'm now going to come up with a second equation, and it's going to be 300 equals a, e, this one's the one that's to the 4b. Now that I have a system of equations, I can use substitution to solve this. Okay, so let's use the substitution. It doesn't matter which equation, but we need to solve one of the equations for one of the variables. So we need to solve for either this a or this b, or this a or this b. It looks like the a's are going to be easiest to solve for. So if I solve for a, let's say I solve for a in this top equation. To solve for a, I would need to divide by e to the 2b and divide by e to the 2b. So I have this statement here. A is equal to 100 divided by e to the 2b. And here's where the substitution is taking place. I'm going to go to that equation that I have not yet used. I'm going to go to this equation that I have not yet used. The second one, the one that begins with 300. And I'm actually going to replace the a. I'm going to replace the a with what we found earlier in the substitution. That's 100 over e to the 2b. Now, I still have to do times e to the 4b because that's right out of our original equation. Okay, so e to the 4b over e to the 2b simplifies quite a bit. What I mean by this is you're essentially, when you're using division with the same base, you subtract your exponents. So 4b minus 2b, I can simplify this statement. 300 equals 100 e to the 2b. And this is now an equation that we can solve for b. What do I mean by that? I mean divide by 100. Get it in exponential form, which we've been doing the past couple days. Once you're here, I hope you're saying, well, that can go into logarithmic form. You're going to be able to say ln, or log base e of 3 equals 2b. So I divide by 2, divide by 2. b is equal to the ln of 3 divided by 2. We can do that into a calculator. Actually type in the ln of 3, enter, divided by 2, enter. So b is a guaranteed value. 0.5493. We'll estimate to 4 decimal places. Well, just because I have found B doesn't mean I have found A. So let's do that part here. I can go back to any equation I essentially want. Let's use the original one. Remember that 100 equals A e to the 2b. That was the first equation we created. Well, I'm actually going to substitute that value in for B. So 100 equals A e to the 2 times 0.5493. So I just need to solve for A, and this is actually a much easier, if I divide by 2 times e to the 2 times 0.5493, I'm just going to put all of this in the calculator. Those are going to cancel, and my answer for A is just all calculator work. So what I mean by that is right here, if I have to do e to the, it is 2 times 0.5493. That's our estimation. So close those parentheses, get an answer, and I want to take 100 and divide by it. A is approximately 33.3. So our final equation, now that we know A and B, what does our exponential graph look like? Well, y equals, we found the A value, that's the 33.3, that's what's in front of E. Well, we don't have to put repeating, that wasn't technically correct. So we'll just do 33.3 e to the 0.5493x.